I'm going to start off with a question that was given to us by KG. KG, thank you for this question. Quite interesting. There was a few first principle questions that you asked me. I'm going to fall away and I'm going to explain the idea of first principle derivatives for you in differential calculus, folks. It works the same across anything that you do in differential calculus. So let's start with KG's question. The question is quite interesting. It's saying the function f of x is given as 3 over x. Now, folks, we identify that as a hyperbola. The question is find the first derivative by first principles. I'm going to shorthand that as first P's. Okay, so remember, what does first principles do? It starts at a point, it fixes the point, it moves h units away from the point, it fixes another point, and then between those 2 points, you have a line that runs there. And you are interested in finding the gradient of that line. Once you've got the gradient of that line, then we're going to bring those points closer and closer and closer and closer together until they're on top of each other. And that will be the answer to the question. Okay, so let's see how this process starts. They've given us f of x is 3 over x. So we are interested in finding f of x plus h. So this step, you move h units away. So if this is my function and this was my first point, I'm now moving h units away from that point to another point. Okay, so this will be the point x and 3 over x over there. I move h units on, and all that happens is the x value increases by h. The x value was x over here. The x value over there is x plus h. And the y value, remember, like for all other graphs, folks, you find the y value of a point by substituting the x into the function's equation, and the result is your y value. So let's do that and see where it takes us. If I substitute my x here with x plus h, that is what I have. So here I have one y value, here I have another y value of these 2 points. So that point will be, this point over here, will be x plus h and 3 over x plus h. And I'm now ready to find the gradient of the line that joins those 2 points. Remember, a derivative is nothing other than a gradient. Okay, so for me now to find that gradient, I'm going to use my grade 9 gradient formula. That's how easy this is. Let's do that. The gradient will then be the change in y over the change in x. So it will be the 0.3x plus h, the one y value, minus the other y value, divided by the 2x values. So x plus h minus x. Now if I clean that up a bit, I can see x minus x takes care of the x's in the denominator, and I've got a problem here at the top. At the top I have 2 fractions. Now this is just a minor complication, folks. It's not a major issue. I'm going to teach you a way to get rid of that fraction. We call this type of fraction a complex fraction. I'm going to teach you a method that will help you get rid of it in one step. Watch the screen. We are now going to, let me just clean that up, 3 times x plus h minus 3 over x divided by h is what I have. Okay, now I see that I've got 2 denominators in this complex fraction. This is still my gradient, my average gradient between those 2 points. If I take this fraction, I multiply it with x times x plus h, and I multiply the denominator with x times x plus h, it immediately takes care of these 2 denominators, and the complex fraction over here will dissolve. So remember, you multiply the first term with this factor at the end, the x plus h and the x plus h cancel each other out, and you are left with 3x minus. There's a 3 that 3 over x that I'm going to multiply over here. In this case, the x's will cancel, so I'm left with 3 times x plus h. Now, matrix, be careful here. You are subtracting those two y values. So put the second y value in a bracket, else you're going to lose the sign change that needs to happen over here. Okay, let's continue. At the denominator level, I have h times x plus h. Now you're going to see how beautifully this cleans itself up. I've got 3x minus 3 times x minus 3 times h divided by h times x plus h. Now folks, you will see at this point I do not multiply my denominator out, because I'm going to see in the next step what is going to happen with this particular denominator. Let me just make space for us here on our page. Okay, there we go. So I'm entering another phase. I'm entering the cleanup phase, so I'm changing color. Those two say goodbye. I'm left with minus 3h at the top. Now look at this. H times x plus h. Now, KG, I hope you're following this. Okay, remember what did I say? You find the f of x is given, you go h units away, you find the f of x plus h, and you apply your gradient formula. So we're still busy in the first phase. Look at what happens here when I clean it up. The h cancels with that h, and this is the function that I'm going to move forward with. The function is going to be, or the expression for the gradient is going to be minus 3 over x times x plus h. Okay, so that takes care of the gradient phase. Now I'm going to move into the derivative. How do I take the derivative with first principles? Well, I said I'm bringing the one point on top of the other point. So what's going to happen? H is the difference between the two x values, and that difference is shrinking to 0. Okay, so let's write down our final few steps in this question. The first derivative with respect to x is therefore the limit when h approaches 0 of the gradient that we just calculated. Okay, that's your definition, folks. Somewhere in your question you've got to indicate that you're doing this. Okay, so we've already got this component. This is what it is. So we keep the limit. We haven't taken the limit yet. And we replace this gradient with minus 3 over x times x plus h. And now we're ready to take the limit. When h becomes 0 here, it means this here, this value will become 0 in the next step. And what does it leave me with? It leaves me with minus 3 over. Now notice I'm not writing down the limit again. Why is that so? Because I'm taking the value of h, which is 0, into this expression. Now whether you're working with a hyperbola, with a line, with a parabola, you're going to do the same thing. Okay, so h is becoming 0, and I've got x times x left, and my result for this derivative by first principles is minus 3 over x squared. Now, KG, this is one of the more difficult questions. It's not really difficult. There's just a little roadblock in the middle of the question, and that roadblock is you're working with a complex fraction. So make sure that you know how to get rid of complex fractions if this question does pop up sometime on a test or on an exam. Now, KG, thank you for that question. I'm sure a lot of viewers at home learned a lot from that question.